Hello there. This is video number 15. And this is chapter 4, section 2. And this is about multiplying and dividing. Multiplying and dividing rational expressions. Okay, so this is where some review of rules of multiplication and division with fractions need to come in, and also some recollection of how to handle exponents before we go any further. So first, rules of multiplying fractions. And I know I've talked about this a few times in this class, but you've been able to kind of rely on your calculator, and here you really can't. I mean, there's some numbers at the beginning and you could, but you should do these without a calculator so that once we add binomials with variables in them, which your calculator cannot do, you have a clue how to actually do the process correctly. So recall that if you have A over B times C over D, that's A times C over B times D. You're just simply multiplying straight across. Okay. So if, for example, you have 4/10 times 5/20, you can just multiply straight across, which would give you 20 over 200. Anytime you have zeros like that, I'm assuming you know you can cancel a zero off of there. And then you're always expected to reduce to lowest terms. So 2 goes into both 2 and 20. So this would be 1/10, right? Easier and almost more applicable in our situation is to cross cancel and take a look how that's going to work. If we have 4 over 10 times 5 over 20, well, 4 will go into 20 one time into 4 and 5 times into there. I can cancel the 5s. They each become 1s. And then if I multiply straight across, I have 1 times 1 is 1, and 10 times 1 is 10, and you're done. So this is the way I learned to do multiplication of fractions. For the majority of you, you've relied on your calculator so much and for so long that you don't really cross cancel. Your multiplication skills are also not as strong as they need to be. So if you need to actually do this process up here where you're actually multiplying first and then reducing, do that. And I think this section actually starts out with number problems like that, and then it moves into variable problems. So that's multiplying. Division, so rules of dividing fractions. If you can multiply, you can divide, which is what I love about these. So you have A over B divided by C over D. There's a rule that I use, and I'm going to give you a couple of them. I use keep this the same, change this to multiply, and flip this one upside down. Keep, change, flip. That's what I will say all the time. I've had a student come in and her teacher taught her copy, dot, flop. So you're keeping it, copying it, changing it, it turns into multiplication, so hence the dot, and then flop this one upside down. Whichever way you're going to go about this, you're going to keep the A over B, multiply, and this becomes D over C, and now you just multiply straight across like you did at the top. So A over D times B over C. So the flopping or flipping, whatever, this has to happen before any reducing or canceling. Okay, so you may have to make sure that you rewrite these first before you do anything else. All right. Okay, and then one more reminder. I want to make sure that you recall if you have something like x to the 5th over y squared over x to the 3rd over ny to the 4th, that you are simply subtracting the powers, essentially. The answer to this would be x squared over y squared, right? And if you're unsure how that happened, if I take this and actually expand it, I get 5x's, that's x to the fifth, and 2y's over 3x's and 4y's. And then I can just cancel like terms top and bottom. So I have 3x's on the bottom. We'll cancel into 3x's on the top. So 1, 2, 3. 2y's on the top. We'll cancel 2y's on the bottom. And what's left over? 2x's or x squared. That is not 2x. It's 2x's. They get multiplied. X squared over 2y's, which is y squared. Right? Or you can simply subtract. 5 minus 3 is 2. Always subtract from the bigger number. And 4 minus 2 is also 2. You're going to have the leftovers where you had more to start with. Whichever way works for you, but you need to be able to do that. Okay, now here's the meat of this lesson. We're going to go through and do a couple of examples. You're going to simplify 5x squared plus 9x minus 2 over 15x squared plus 2x minus 1. We're going to divide that by x squared minus 4 over 3x squared plus 13x plus 4. All right, so the first thing you need to do, because this is a division problem, is rewrite this as a multiplication problem. And what I would do if I was doing this, we're also going to factor. I would factor as I rewrite it so I don't have two steps. So that's what I'm going to do here. So I'm going to factor the top. We're going to use x method here, x method here, difference of squares here, but that'll become your denominator, and x method here, right? So we have a negative 10 and a 9 has got to be 10 and negative 1. Divide by 5, and reduce. So the top of this is going to be 2 over 1. So that's going to be x minus 2 times 5x minus 1. Okay, and then, right, that's x minus 2. This is 2 over 1. Yeah. And then the bottom one here is going to be negative 15 and 2. So that's got to be a 5 and a 3. Divide by 15. Divide by 15. And so this is going to be a 1 and a 5. So that's going to be 5x. Oh, did I miss a sign somewhere? Sure did. 5 and negative 3. So that's going to be the left-hand one is going to be a 1 and a 3. So that's going to be a 3x plus 1. And the right-hand one, if I reduce, it's negative 1 over 5. So that's 5x minus 1. All right, so we factored the top, factored the bottom. That's the left-hand fraction. Change it into a multiplication problem. Here's my fraction. This guy's easy because it's difference of squares, and he's going into the denominator. And then this current denominator is going to become my numerator. 12 and 13. Well, that's got to be 12 and 1. And I'm dividing them both by 3. This is going to be 4 over 1. So that's x plus 4 and 3x plus 1. All right, so now I can go through and cancel any common factors. Now, after you factor, go through and cancel. I should say cross cancel. I won't, but that's the indication because top and bottom, right? Cross cancel any common factors. And you're going to find that they always have some. If there's not at least one, you've made an error in your cancel or your factoring. So 5x minus 1 can go. I have an x minus 2 in black and in red. Those are going to go. I have a 3x plus 1 in red and in blue. Those are going to go. And what do I have left over? I have x plus 4 over x plus 2. And that's my answer. Okay? And you're going to write that way. Again, in varsity, when you type these, make sure you're putting parentheses around you wouldn't write it that way, but you have to type it that way so that the right things are divided. Okay? All right, here's the next question that we're going to do. Add a page. Okay, so divide and simplify. Here's the problem. X squared minus 1 over x cubed plus 1 divided by x cubed minus 1 over x minus 1 times, the way it's written in varsity, it just looks like x squared plus x plus 1. If you need to think about this as being over 1, you can. It won't affect it at all, but some of you might need to do that. So first thing we got to do here is change this to multiply and flip this one upside down. And I'm going to do some factoring as I go. So this guy is a difference of squares. So that's going to give me x plus 1, x minus 1. This is a sum of cubes. That's going to be x plus 1 times x squared minus x plus 1. Change the division to multiply. Flip this guy upside down. So the x minus 1 is going to go on top. And this guy is a difference of cubes. This was a sum of cubes, right? So when I factor that, I'm going to get x minus 1 times x squared plus x plus 1. Extend that bar. And then I have times x squared plus x plus 1 over 1. All right. Everything's factored. Also, just a reminder, if you need to review or you need formulas for these guys, right? Because we had formulas to generate these. They are back in sum and difference of cubes. Sum of cubes and difference of cubes, socks and docs are 1.6. So you have those formulas in your notes. And difference of squares is 1.5. All of chapter 1 was factoring. All right, so now what can we cancel? We have an x plus 1 and an x plus 1. We have an x minus 1 and an x minus 1. We have an x squared plus x plus this trinomial is the same as this trinomial, so they can cancel. And we're left with this little bit here. And what I just did is what you're not going to do for an answer. You're going to rewrite these. And that is your answer for this whole thing. All right. So if you can handle those kind of problems, you will be very successful in this part of this chapter. All right. And that's it. So toodaloo for now.